Hi everyone. Today we're going to discuss about basics of physics by including motion diagram, particle models, vectors and scalars, time intervals, and displacement. Well, let's start with motion diagram. A motion diagram is a series of images that shows the position of an object at an equal time. You can see the helicopter. You can see that the distance is increasing and it's going toward the right. You can see that it depends on different time intervals, or as the time increases, the distance or the displacement of the helicopter change. Well, for a particle model is when you replace an object with a single point. It's just like replacing the helicopter with points, as you can see. Well, vectors has both magnitude, which is size, and direction, and can be represented by an arrow above the symbol, like V an arrow towards the right, and X an arrow towards the right, as the same for A and F. So an example of vectors, which we know vector is a unit that has magnitude and direction, so like velocity, acceleration, and force. So velocity, 20 meter per second, which is the magnitude, towards the north, which is the direction. Acceleration, 10 meter per second square, towards the east, and force is 5 Newton toward the west. For scalars, doesn't have direction but does have magnitude. So example of scalars are speed, distance, age, and heat. So all of those has magnitude but doesn't have direction. Like speed is 20 meters per second, distance is 10 meters, age is 15 years, and heat is 1000 calories. Well, we would use for this example Pythagoras theorem, which states a square plus b square equals c square. So, this is the example that we looked through. So we know that a, which is 2 meters, and b, which is 3 meters. And we can replace a and b, whether you can change a and b. You can put a as 3 meters and b as 2 meters. But I will leave it as that. So replacing the symbols with the numbers that we have, 2 squared plus 3 squared equals c squared. Because we want to get rid of the squared that the c has, we would use square root. Putting square root 2 squared plus 3 squared, which will give us that c equal to square of 30. And subtracting vectors is a bit different because it has different directions, as you can see in here, 3 meter east and 4 meter west. You know that those are opposite of each other. We can know that east is toward the right and west is toward the toward the left. And so minusing those two vectors will give us 1 meter east, and it's the same doing to up and down, which is 2 meter south plus 3 meter north. You can put minus or plus because we know one of them would have a negative sign because it's as opposite directions. So minus 2 plus 3 would give us 1 meter north. Time interval is the difference between two times. So you can see the triangle in here, which we call delta, which is this. It represents change in. Well, for this example, or for this equation, is the change in time, which equals time final minus time initial. So let's look at an example. For this example, it took the ball 30 seconds to reach the ground. Calculate the change in time. So we know the change in time, which is delta, and we know the equation of it, which is delta t equal to tf minus ti. So it took the ball 30 seconds, which is the final, and the initial, which is 0. So change in time would be 30 seconds. So displacement is change in position, and it has both magnitude and direction, which we can say displacement as a vector. So the equation of displacement is delta x equal xf minus xi, which is the change in displacement equal final displacement minus initial displacement. Let's look at an example. Sarah threw a ball down a hill with an initial displacement of 3 meters. They gave us the initial displacement, which is 3 meters, so we will highlight that, and a final displacement of 10 meters. So they want the change in displacement. So we know the equation of change in displacement as I just taught you, which is the delta x equal xf minus xi, and we replace x by the numbers as they just said. Xf, which is the final displacement, is 10, and the initial displacement is 3. And minusing those by using the equation would give us 7 meters down the hill. And thank you for listening, and hope that was helpful.